Hey guys, welcome to the notes on 7.1. We're going to start getting into inverse trig functions. Okay, so let's start by looking at the graph of y equals sine of x. Here's the problem. It doesn't pass the horizontal line test, which means the inverse is not a function. So what mathematicians do is we isolate just a certain portion of the sine curve, and we say, well, on that interval, the inverse is a function. Okay, and we're going to call this y equals sine -1 of x. That's inverse sine. Now remember, for inverse functions, the domain is the old range, and the range is the old domain. Okay, and keep in mind, we're restricting the interval from here to here. Okay, we're defining the inverse function only on that portion. So the domain of the inverse sine is the range of the original sine. Okay, so notice that the range of sine goes from -1 to 1. So that's going to be the domain of inverse sine. And the domain of our restricted sine is negative to positive pi over 2. So that's now going to be our range, negative to positive pi over 2. Okay, so they just swap. Now let's do the same thing with cosine. So y equals inverse cosine of x. And let's define our interval. So notice again, cosine does not pass the horizontal line test, which means its inverse isn't going to be a function unless we restrict it to a certain portion. And mathematicians decided that for cosine, they are going to isolate the section from 0 to pi, because that section passes the horizontal line test. So when we find domain and range of inverse cosine, we're restricting it to this interval. Okay, the domain is going to be the old range, so -1 to 1. The range is going to be the old domain, but only our restricted area here from 0 to pi. Okay, and let's do the same thing with tan. Now, tan does pass the horizontal line test in one period, so we don't have to worry about any restrictions. So let's look at inverse tan, and let's find the domain and range. Okay, so the domain of the inverse is the old range, and notice it goes from -infinity to infinity. So that's the domain, or all reals, if you prefer. And the range is the old domain, negative to positive pi over 2. And we're going to put parentheses, not brackets, because they're undefined there. Okay, so unit circles back. When we talk about inverse trig functions, we're trying to find the angle that produces this ratio at this trig function. Okay, so where on the unit circle, at what angle in radians, is sine -√2 over 2? And I hope you guys are thinking, well, that happens twice, in quadrant 3 and quadrant 4, but keep in mind, we need our answer to be between negative and positive pi over 2. So actually, I'm also going to draw you guys a picture here. When we're doing inverse sine, we want our angle to be between positive and negative pi over 2. When we're doing an inverse cosine problem, we want our answer to be between 0 and pi, so either quadrant 1 or 2. And when we do tan, inverse tan, we want our answer to be like sine from positive to negative pi over 2. So in quadrants 1 or 4. So go back to this problem here. Where is sine -√2 over 2? Well, sine is negative in the third and the fourth, but we only want the one in the fourth quadrant because of our restriction. Okay, so what is this angle in the fourth quadrant where sine is -√2 over 2? That's going to be negative pi over 4. Now, some of you might have said 7 pi over 4. And you're right, but we need it to be within these two numbers, and 7 pi over 4 is outside of this range. So you really have to be careful how you guys write it. Okay, example 2 is saying, at what angle is cosine negative root 3 over 2? Okay, but remember, our answer has to be in quadrant 1 or 2. So it's obviously going to be in quadrant 2. Okay, so what is that angle where cosine is negative root 3 over 2? Well, it's going to be some version of pi over 6. So in the second quadrant, that's going to be 5 pi over 6. Okay, and then example 3, at what angle is tangent negative root 3? And we need our answer to be in the first or fourth within this range. So tangent is pi over 3 at the pi over, root 3 at the pi over 3's. So it's going to be negative pi over 3. Okay, and I'm just getting these from the unit circle. Okay, flip it over. Using a calculator. Oh my gosh, you guys, I don't have a calculator with me and I don't want to stop the video. So we can talk about this in class. But basically, make sure you're in radians. And I can't pause the video while I'm in it. Go to radians and see if you guys can type in inverse sine of this. Inverse cosine, inverse tan. And I promise I will give you the answers the next time we're in class. Okay, moving on. So these are actually some of my favorite problems to do because most of the time they just cancel. So if your angle is within the correct range, if you inverse sine a sine, they actually just cancel. They undo each other because inverses undo each other. And whatever this number is, that is your answer. So these are super easy. The only problem is if this number is outside of the range, then you have to convert it to an angle that is inside the range. For example, number 8. 5 pi over 8 is not within our range of negative to positive pi over 2. It's outside of that range. So we need to rewrite it as an angle that is inside of our range. Okay, so how do we do that? Let's see. Where is 5 pi over 8? That's going to be somewhere over here, right? Almost at 8 pi over 8. So basically, you could just find the reference angle. The reference angle would be 3 pi over 8. So that means that 5 pi over 8 would actually produce the same sine ratio as 3 pi over 8, which is within our range. Okay, so actually on this one, inverse sine and sine cancels, but since this is out of the range, we converted it, and the answer is 3 pi over 8. Okay, now let's take a look at number 9. Now number 9 is actually backwards. The inverse is on the inside. Okay, so now when you look at the inverse sine, the domain, remember, has to be between -1 and 1. Okay, and 0.8 is, so we're good. If you sine and inverse sine, they cancel. And the answer is just 0.8 or 0.8, whatever. Okay, so notice if the inverse is on the outside, you're going to end up with an angle. If the inverse is on the inside, you're going to end up with a ratio of the sides or a decimal. Okay, number 10. Inverse cosine a cosine cancels as long as this angle is within cosine's range. And pi over 12 is between 0 and pi, so that is going to be the answer, pi over 12. They just undo each other. Okay, now look at 11. If you inverse cosine a cosine, they cancel as long as this is within our range of inverse cosine. But unfortunately, 13 pi over 12 is outside of the range 0 to pi. So we need to find the reference angle and write it a different way. Okay, so let's see. So 13 pi over 12 is just pi over 12 more than pi, right? 13 pi over 12 minus 12 pi over 12. So the reference angle here is pi over 12. Now, cosine is negative in the third quadrant, so we need to find somewhere in the first or second where cosine is also negative. And that's going to be this angle here, which is 11 pi over 12. Okay, because if the reference angle is pi over 12, then pi over 12 away this way is 11 pi over 12. Okay, so then inverse cos cancel, but we want the 11 pi over 12 version because it's inside the range. Okay, and then number 12 is actually more like this one. If your inverse cos is on the inside, remember the domain of an inverse cos is -1 to 1. Now pi is outside of that range. Pi is 3.14. So this is actually undefined. If it's not within the domain, you cannot do it, so undefined. Okay, and then one last one here. It says solve for x. Okay, so I'm going to start by just dividing by 3. So I can isolate my inverse sine of x equals pi over 3. You guys agree with that? So another way to write this, if this helps to think about it, is you're trying to find out sine of pi over 3 is what? That's another way to translate this into maybe something that looks a little easier to solve. So the inverse sine of what gives you pi over 3 means sine of pi over 3 equals what? Okay, so what's the ratio at sine of pi over 3? And hopefully you guys are saying that it is root 3 over 2. And that's it. All right, thank you guys for watching. We will practice this in class next time I see you.